So let us see second example on formation of the generator matrix or parity block when the parity bit equations are given. So here C1 given it as M1 M2 M3, C2 M2 M3 M4, C3 M1 M2 M4. So here you can observe that there is M1 also M4. That means it is a 7,4. That means message has 4 bits. So it is a 7, 4 and parity bits are 3. So it is a 7, 4 LBC. So generator matrix has the form IK, this one, and we have to form this parity block by this equation. So this corresponds to C1, then C2, C3, C4. C1 is nothing but M1, C2 M2, C3 M3, C4 M4, because in systematic first bits are message bits. Now this is your parity bit first, which they call it as C1. So here you have to remember or you can say that first row corresponds to M1, second row corresponds to M2, third row corresponds to M3, and fourth row corresponds to M4. So in C1 there is M1, M2, M3. That means you have to write M1 in the if M1 is there, right, you have to write 1 in the first row, then M2 is there, so 1, M3 is there, so 1. For C2, M2, M3, M4. So M2 second row, so write 1, then M3 1, then M4 1. M1 is not there, so 0. For C3 it is M1, M2, M4. So first row M1, so 1, then second row M2, so 1. M3 is third row, it is not there, so 0. And fourth row is M4, it is there, so 1. So this is parity bit 1, this is the column of parity bit 1, this is the column of parity bit 2, and this this is the column of parity bit 3. Let us take this example. So this is 6, 3 generator matrix. So first is a identity matrix. So this is C1, C2, C3, C4, C5, C6. Identity matrix of 3 by 3. First row corresponds to M1, then second M2, then third M3. So C4 is M1, M2, so 1, 1. C5 is M1, M2, M3, so 1, 1, 1. C6 is M1 and M3, so 1, 0, 1. M2 is not there, so 0. Column corresponds to parity bit. Column corresponds to parity bit and the rows corresponds to message here, because if you do the multiplication you will come to know that how parity bits come and how message bits are multiplied.